Hello and welcome to today's daily Leetcode challenge. Today I'll be going through question 706, design a hash map. I'll be going through my thought process as I come up with a solution and then stick around for the end of the video where I compare my solution to the solution of others. With that, let's begin. Question 706. So, Okay, so 706, design a hash map. Design a hash map without using any built-in hash table libraries. And it's pretty obvious that pretty much every language has its own implementation of a hash map. Some call it a dictionary, some actually call it hash map, etc., etc. Implement hash map class. A hash map initialize the object with entry map. So we need to call something like uh, h equals uh, oops map. That would call the init uh, function. Why didn't the s hash map? We need to have a put, so h put. We need to have inserts key value pair into hash map. If key already exists in the map, updates the corresponding value. Get, so we need an h get. So returns a value to which the specific key is mapped, or -1 if the map doesn't contain no mapping for the key, and remove. So h remove. And I mean, in why don't some characters are just not are just not writing? And I'm writing this all on an iPad by remove. Um, so it's weird that it's not displaying here. So yeah, for those who know Python, the answer to this is pretty much just a dictionary, and you interact with it by uh, doing this. You could create a dictionary like this, or even just like dict like that. And then to put something in, you would say h, then the key goes here equals value, um, key value, and then you would get it by doing h, um, maybe like this. Val is equal to h k. But we're asked to not use any of these. So we can't use any of the defaults. And so what I'm going to show you today is how to implement a hash map with a regular array and this function hash, which by the way exists on, I'm pretty sure, all the default uh, or the primitive types in Python, but also on tuples and any static type of um, static types in Python. So for example, an array would not have the hash implemented, but an int, a tuple, a string, they all do. Characters even, I believe. Anyway, okay, cool. So with that, let's begin the question. So what I'm claiming is I can implement the uh, hash map with just this just this function hash. This is how I'm going to do it. I'm going to have an array, and I'm going to draw it vertically. I'm going to have an array of values that are initially, or I'm going to set it to a specific length. I'm going to say that self size is equal to some arbitrary number. It can be 100, it can be 200, 1,000, million, anything you want, which is just going to be basically the len of this array. Array. And what that means is that, yeah, I mean, this thing has 100 entries. Initially, they're all none when I when I call when I call my constructor here. They're all none. But with every put, I'm going to do the following thing. I'm going to say this is my input value, key value pair. I'm going to say that my index is equal to and the index is going to correspond to where this value lives in this array. My index is equal to hash of the key modulo size. Modulo size. So keep in mind, so hash of the key modulo size. So hash is going to give me a huge number. It's going to give me like a huge and very weird looking number. It can be like 2, 3, 7, 9, 8, 4. But if I modulo this by 100, which is just the size here, I'm essentially getting this number to a value from anywhere from 0 to 99, which is guaranteed to be somewhere in this hash, in this array. And what that tells me now is that it tells me in which of the 100 elements here, which of the 100 elements I should put my key value pair. Now, you may be wondering, well, let's say that I have like this huge number and I have this um, number. Uh, the modulo of both of these by 100 is actually just going to be equal to 1, both of them, because, um, well, 1001 modulo 10 is going to be 1, and 29,000 or 2,901 is also going to be 1. If you don't believe me, you can check it yourself. So what would that mean? That would mean that both of these values, the key, and the key could be something like this. Um, oops, sorry. 1001 and key could, oh, or value could be like 1001. And another value would be like 2901, and value would be like 2901, right? These are strings. They would both be in one of these, in the same essentially subarray. They would all be in the same subarray, but what I'm going to do now is um, I'm going to basically just store both of these values in here, one in the 0th index and one in the next index. And essentially after that, the rest of the work is just going to be searching only this array. But what that helps me do is if this number, if this 100 is big enough, then it distributes the search that I have to do from, let's say that I have, uh, let's say that I have, I don't know, um, that the numbers that I input here is like 1,000, 100,000, right? Well, what this would do is it would just divide the number of like the ON of finding an element in a 1,000 um, element hash map from O1 to ON divided by 100, which this is actually just the size, right? And so you could see that for large elements, for large data sizes, this size could actually be anything you want. You could get it equal to like 1,000,000, 1,000, 100,000, 10,000, whatever you want. The point being is that it's going to decrease uh, the size, the time it takes for you to find some element essentially by this size. And Python, for example, does this as well. The dictionary that we all know does have a sort of like limit on what it can actually be. So on what the size value is. So it always has some default and even at some point some dynamic way of scaling to to essentially try to get it to O1 as close as possible. But it's there are instances where searching for an element in a hash map doesn't actually equal O1. It could be O longest of the longest one of these subarrays. Cool. And so with that, I believe that we are ready to start our implementation. Put away drawing tool. Cool. Let us begin. So, and I'm going to be doing a Rust video on this later, but for now, let's do Python. Self size is going to be equal to some arbitrary number. Let's call it 100. And then I'm going to say self R is going to be just a array of empty array for in range self size. Cool. So for now, I have this two variables and data structures. I have the self size equal to 100, and I have this array, which in itself has a bunch of nested arrays in it. Cool. So now what would I do with a put? Well, let me say indx, which is going to be telling me to which of the 100 sub arrays I'm pointing to, is going to be equal to hash of the key modulo self size. Now this index is now pointing me to which array I'm going to be inserting this value to. And now simply do a for loop. Let's say that I have indx. Let's call it sub indx because it's actually just pointing me to a sub array. For let's say I have a key value pair, but I want the key and the key value in enumerate self R. I'm going to say that if k is equal to key sub indx equal to I. Cool. And now if sub indx is not none, meaning that we found an element, but because, by the way, if I put on a key that already exists, I have to replace it. Self R indx, which points us to which of the subarrays I am in, and then the sub indx, which points me to the actual element, is going to be equal to the key value pair that I am actually at, right? So as I said before, each one of these subarrays is going to store the key and the value pair of what I'm trying to insert. And this is what I would do in the case where I found an element that already exists. And else self R at a specific subarray is going to be equal to just the new key value. So I'm just appending it. Why am I appending it? Well, because there's a chance that it's already a bit populated. So there we go. Now let's see. Sub R. So I would equal this to sub R. Cool. So now, what do we do for a get? Well, it's pretty much the same thing as this, I'm simply initially finding the array, the subarray, which my element definitely resides in. And I actually don't need this guy here, and I don't even need to enumerate. All that I'm going to be doing is checking that my key is equal to the key that I'm passing. And if that's the case, return v. And if I don't find anything, return -1. So same thing, indx for this in indx. Oops, I missed that in here as well. I need to look over a specific sub array, not all these subarrays. Cool. Now we've implemented get, and finally remove. So again, the same pretty much idea here. Let me just copy this. And yes, obviously copying code is bad, but let's see. So if I stumble on a array, on an element that I've already added, then I'm going to say simply delete self r indx at a specific index. Oops, I really do need the index here. And what I could do, I guess, is, okay, let's see, I found the index. I really don't need the, I still need the key value. Okay, I'm gonna not use this value because I don't need it. For I key and key equals key, delete some element at I. And that's it. Let's see if it runs. And I'm gonna, cool, it does. I'm gonna make it a bit better. I'm gonna say that def get indx by the some key of int is going to give me also some int. And I really just want to do this so that I don't have to worry about ever rewriting the get indx function. Now where would this setup with the array not work? Well, as I mentioned before, all of the primitive, I believe, functions or objects implement the hash function. But if you were to implement it yourself and on top of that incorrectly, you would have issues here. You also need to be sure that the equals dunder. So, and I'm talking about these two functions, hash and equals. Now these are functions that you can override on you have to implement on any object that you write yourself, and you could override them for ones that are defaults. And so where would this cause issues? Where you potentially override but two were given. All right, because I'm calling self. Let's see, I don't have to call self on this at all. Or although, no, yes I do because I have self. Okay, so, oops. Let's get this equal to self, and I'll say self. And that's it. We need self because we need access to self.size. And this is gonna give us a response. It's going to say that we did it correctly. Let's see how well we're doing. And I'll show you something interesting. Beats 50%. Let's increase this number by a lot. Let's say that it's now, well, what's the max here? To the fourth? Yeah, let's say to the fourth. Now it's going to do it in essentially a 1 on average because there are there are only 10 to the power of 4 elements in here. So now we're going to be beating even more people. Well, theoretically, you should be. Let's see. Did any of these people implement it correctly? No. So they're using the dictionary under the hood, which is, I guess I would say it's cheating. Yeah. The correct way to do this would be over uh, using an array, or at least that's what I've been taught. Okay, well, I hope that this gives you some insight into how hash maps are actually built, for Java at least, and for maybe more non-script languages. Cool. Yep, let's keep this video short again, and I'll see you later. Thank you. Bye.